not going for Oscars. I just need data. Okay. So, now, on your example, in your alkanes, alkenes and alkynes, your carbon chain, I've always had you have the double bond or the triple bond at position 1. It just makes things easier. But that double bond in an alkene could be here or here, you know, and so that is reflected in the name of the molecule. So if you look at the carbons, position 1, 2, 3, 4, and that's a bit of a misnomer because if I grab that and turn it around, is it not the same molecule?
It is.
So you could go. I can also read it 1, 2, 3, 4, depending on how you want to go with things. So what we have here is at the first carbon there is a double bond. So 1, 2, 3, 4 carbons is what prefix? Methane, ethane, propane, butane. So, and is it butane or a double bond means it's butene? And the first carbon has the double bond on it. So the name of this is but-1-ene. The 1 refers to the first carbon having the double bond. So but-1-ene has a double bond at position 1 carbon. But-2-ene has the double bond at the second carbon. So that's what's happening in terms of a naming convention. So you could be asked, draw the molecule, say non-3 iron, non-3 iron, non would be 9, and at the third carbon I'd need a triple bond because it's an iron. Okay. So this is how these naming conventions work. The ene or the iron name indicates the carbon atom on which the double bond or the iron triple bond is found. Okay, there's another example down here, this time as a structural formula. CH3, CH2, C, triple bond, CH. So this is the first carbon reading that way. So it's, now in this particular textbook, this is butane and they put the 1 in front. That happens in some textbooks, but I confirmed with Mr. Waldron yesterday, we will be using this nomenclature. So we'll be using the but-1-ene, but-2-ene. We'll be putting the number before the ene or the iron. Yes?
And also making sure we don't have to show the single bonds.
No, you never show the single bonds.
Yeah.
That's a bit sloppy, isn't it? Yeah, it's sloppy. Well spotted. And here is but-2-butene. At the second carbon, there is a triple bond. And so that particular naming convention you need to be familiar with. And there's one other thing that we'll have a look at now, and that is constitutional isomers. Now, for them, it's a little bit tricky. Make that a bit larger. Compounds that have the same chemical formula or molecular formula, but different structural formulas. So what does that mean? C4H10, butane. How many carbons? Not your question. 4. How many hydrogens? 10. C4H10. Also, same chemical formula, but this is 2-methylpropane.
Drawn different.
Well, that's what a constitutional isomer is. It has the same chemical formula, but a different structural diagram. I should put structural diagram rather than, or structural formula would be fine, and structural diagram. Let's have a look. We've got our 4 carbons. This is a standard alkane structure. But here we have, what's the longest carbon chain that you see here? How many carbons are the longest chain? 1, 2, 3 carbons. Now 3 carbons has what prefix? Methane, ethane, pro, or prop. Yep. 3 carbons will get you prop. Okay. Now, are there any double bonds? Okay, so it's an ane in terms of only single bonds, and a CH3 group like that is called a methyl group. CH3 out the side is called a methyl group. And finally, what carbon is the methyl group on? What position is that? That's the second carbon. 1, 2. So, what the name means, on the second carbon of propane, there's a methyl group. Got it? So this is the prop, means 3 carbon, ane means single bonds, 3 carbon with single bonds, and there's a methyl group, CH3, on the second carbon of propane. Yes?
Could you have like 2 methyl prop 1 ene kind of thing?
Yeah.
Oh no.
I'll jump. Don't worry, I'll come back. You mean like that, 4 methyl non 2 ine?
Yeah.
Absolutely.
Why?
But that's not year 10 level. That's a little beyond where we need you to go. These two are in the ballpark, and these are definitely capable. Things you're capable of. So I'll go back so people can complete their notes. But do you understand this idea? The name, that particular name, is actually pretty logical. Okay? If I gave you a 3 carbon chain, you'd say propane, or propene, or propine. You'd look at the number of bonds and the length of carbon. And that's what we've got here. 1, 2, 3 is prop for 3 carbons. There are only single bonds, so it's ane, propane. And then we have a methyl group, CH3, and it's only going to be that. You don't need to worry about that. I've got a CH3 stuck out the side of the second carbon of my longest chain. So it is in fact a second, I've got a methyl group on the second carbon of my propane chain. And that's it. And that's fundamentally what this information is down here. Okay. Any other questions? Yes?
Wait, so when you say different structural formulas, I know you said it before, but like it's more structural diagram?
It should be structural diagrams, yes. That's probably would be better wording because some textbooks say structural formulas for pretty much everything. It's true also, you're going to have a different structural formula because, for example, what is the structural formula for this? It's CH3, yep, you're on there, yeah, CH3, great. And then how many CH2s?
2.
So I'm going to do it as a structural formula, not condensed, and then CH3. Is that fair enough? CH3, CH2, CH2, CH3, yeah? Now, same chemical formula. Let's do this one. I have, what's that? A CH3, and then I have a CH, and then I have a CH3, and then sticking out the side here, I have a CH3 methyl group. And that is the, and there's only single bonds. So, that is the structural formula for that 2-methylpropane, which you should be able to, I'd probably add that to your notes. Okay, you might be asked to draw something like that, and that is the structural formula of butane. So it's both structural formulas and structural diagrams are different, but the chemical formula, the molecular formula are the same. In both cases, C4H10, 4 carbons, 10 hydrogens. Any questions? So the next work activity that we're going to go on with is going to help you practice this. Don't worry, I'll go back. This, changing where the double and the triple bonds are, and practicing this, constitutional isomers. Yes?
Could you have 2 ethyl propane and then have like 2 carbons?
2 ethyl propane.
So about the second.
I think you probably can. I mean, it's effectively unlimited. But in terms of when we talk about, there's a wide range of possible molecules, and all of this is pumping out of oil wells. Yeah, it's a mistake to think that oil, it's all black and it's a liquid. It's all the same. I mean, no, it consists of thousands or tens of thousands of different hydrocarbons. And then there has to be some kind of sorting process to get those of about the same size into different storage tanks, and they have different functions. They're used as different fuels. Okay. Any other questions? There. So the exercise we're doing today is that table there has to be drawn in your book, and you have to have, now in hindsight, rather than do the chemical formula first, I think do the structural diagram first. It makes things easier, because from the structural diagram it's very easy to read off the condensed structural formula and the chemical formula. It makes it a lot easier. And you're going for, well, but2-ine. But means how many carbons? Methane, ethane, propane, butane is 4. Is it a single, double or triple bond somewhere?
Triple.
It's a triple bond somewhere. And at what position is that triple bond? The second carbon. On the second carbon of a butane chain, there is a triple bond, is what that is saying. So it's quite logical. Most people, I think, will go through these with not too much difficulty. And then when we get down here to the constitutional isomers, it becomes a little more challenging, but still doable. I'll come around and I'll help people, and we'll go